Hello, I'm Mark Pollitt, and welcome to our presentation on undeleting folders and recovering long files by use of the chaining technique. We begin this portion of our instruction with our DOS machine up and running and a floppy disk mounted, which is floppy disk A. So let's take a look at that drive. And we'll do a directory, and we can see that there is a single directory in there. The volume name of the drive is chain. There's a single directory AC. If we go to that directory, we can do another directory, and we can see that there is a file in there called long.txt, and it's 1444 characters. So we've got a single directory and a single file in our floppy disk. So we're going to go ahead and we're going to erase both the file and the directory. From this directory here, we're going to delete long.txt. And as you can see, it's gone, and we're going to go back up to the root directory. And remember, the ... points to the parent directory, so if I do a cd ... it will take me back to the root directory. And I can see that I still have the AC directory there, so I'm going to delete that, and the command in DOS is rd, and it will go ahead and delete that directory. So now we have deleted both the directory and the file that was inside that directory. Now we're going to start disk edit. And as we can see, since it's running on the A drive there, that at the root directory we have the volume name chain, which we knew about, and we have a deleted directory sigma C, which is erased, and of course the root directory starts in 0, and the first cluster is 2. So we can see that the cluster is there, and if we go into that cluster, we go to cluster 2. It will show us the directory listing there, and go from there. And if we come down here to the long.txt, that's in cluster 3, and if you look down to the very bottom here, you can see where you can start to read it, although it's trying to interpret it as a directory, so that's why it looks a little funny. But the long and the short of it is we can see our deleted file here. So we're going to go ahead and we're going to go ahead and undelete these. The first thing we're going to have to do is we need to start with the root and work our way down. So if we were to have deleted files here as well as a deleted directory, we would need to delete all of them at the root directory first. My suggestion is to do them in the order in which they're in the directory, and to completely restore each item before you move on to the next one. In other words, don't try to do the directory listings for multiple things and then go in and start to do the file allocation table. Take it in one step at a time, just like you're going to see me do in this video. So in this case, the first thing we're going to need to do is we're going to need to eliminate the sigma and overwrite that hex E5 that's in there. We don't officially know what the original character was, so we're going to use the bang or exclamation point for that. And so we're going to go ahead and write that. We know that we need to do the file allocation table, so we're going to go Alt-A and go to the first FAT, and it'll ask us if we want to write it, and the answer is yes, so we will write it, and it'll take us immediately to cluster 2. And you can see that cluster 2 has got a 0 in it, which means that it's available. but we know it's not available. It is a special purpose file, which is what a directory really is, and since that directory is one sector long, or one allocation unit long, or one cluster long, which is all the same thing in a floppy, it's in use, so we have to put an E for an end of file. So let's go back to our directory entry now, and of course it will ask us if we want to write this and synchronize the FATs, and of course the answer is yes, we want to do it. And it says, do we want to rescan? And the answer is yes. And so now it shows us that we have a root directory, and we have this this directory called bang C. And I'm going to go ahead and go to that. And again, here we have our deleted file. Now, the first part of this is going to be fairly straightforward. We're going to, again, go through there, and notice how I move the cursor one over so I can backspace over the sigma, and then we will put the bang character there, because again, we don't know what the original character was. Now, this is fine, but before we go on, I need to add something here to it that you need to know. The first thing is you want to make a note of the size of the file and the starting cluster. Okay, so in this particular case, the file is 1,444 characters, right, and it starts at cluster 3. Now, that's going to be important to us because when we recover the file, it's very simple to recover the first cluster. But then we have to add the rest of the clusters to build the entire file. And we have to know how many clusters to add in order to put that file back together again. And of course, this is presuming that the file is sequential, that it's not fragmented, as we say. But in this case, we only have one file on here, so we can reasonably assume that it is, in fact, sequentially numbered. So we know that our first cluster is going to be starting at cluster 3, but the file contains more than 2 clusters worth, which would be 1024, and less than 3. Because if it was 3, we would have a total of 512 times 3, which is 1,536 characters. So we know that we're somewhere between 2 and 3, and of course we always have to allocate more rather than less. So we're going to have to chain together, and that's what it's called, chaining, 3 sectors, or 3 clusters in this particular case. And so the way we have to do that is to go to the file allocation table. So the first thing we're going to do is go Alt Object, and we're going to go to the first FAT, and we're going to say yes, we want to write these changes. And so now we're at cluster 2. Well, that's the directory it's already allocated. We know that we started, and I'm tabbed over, use the tab key to move over to cluster 3. Now we know that this is the start of our file, and that first cluster is not the end of the file because it is composed of 3 clusters. So we're in cluster 3. Where do we assume that the rest of the file is going to be? Well, if it's in sequence, the next part of the file is going to be in cluster 4. So in cluster 3, which is where we're at right now, you look at the lower right there, you can see cluster 3, we're going to go ahead and put in the number 4. And the reason for that is we're saying the next cluster is over in 4. So go over and read cluster 4. And then we're going to tab over to what is cluster 4, and since we know that there's one more cluster on this, then we're going to go ahead and put cluster 5, right? Because we're pointing from 4 to 5, right? Correction, 5, right? And the last one, the third one, right, which is cluster 5, right, we know that's going to be the end of the file because that's where the file ends itself. So if we put an E there for end of file, we now have cluster 3 points to 4, cluster 4 points to 5, and cluster 5 is the end of the file. So we have accounted for all 3 of the clusters that make up that file. So let's see if that works. We go Alt Object, and we're going to go to Directory, right, and we're going to go ahead and write and synchronize, and we're going to rescan, right, and it didn't give us any errors. That's a good thing. And it comes through and it says, okay, bang long.txt starts at cluster 3. If we go ahead and hit enter, it says, okay, here is a long text message. I will continue to type random characters from here. And if you go down, you can see until you get to the third cluster, and it ends at a little bit above the end of the third cluster. So we have successfully recovered a directory and a file. Remember, a directory is nothing more than a special purpose file. You recover it by changing the first character from the hex E5 to something else, and going to the file allocation table and making that particular cluster occupied using the end of file character. In recovering files that contain more than one cluster, we have to chain those clusters, and we do that by recovering the file name first. Then we go into the file allocation table and we start where the file begins, the first cluster, and the first cluster we put in the next number to point to the next number, and we keep going until we reach the end of the file. And the last cluster that has the end of the file we put as end of file. So this is how you recover chained files that are more than one cluster, and how you recover directories. Till next time, have a good day.